Investigación incluyen la investigación de interacciones entre los dominios cognitivo y afectivo en el contexto de temas sociocientíficos, sustentabilidad, resolución de problemas y estructuras del conocimiento. También ha desarrollado talleres para estudiantes de bachillerato sobre la implementación de métodos socioconstructivistas y el uso efectivo de herramientas tecnológicas en las clases de ciencias. El día de hoy el doctor estará presentando el seminario Cumpliendo tus sueños y despertando la pasión de los estudiantes por la química, cambiando de un enfoque en los conceptos teóricos al dominio concreto de la realidad. Damos la bienvenida al doctor. Thank you so much for being here with us today.
All right. I'm not going to use the microphone. I hope that you're going to hear me fine. Can you hear me fine at the back rows? Okay, perfect. I'm going to speak as loudly as possible. And today, and first, I would like to thank Adriana for inviting me. Alejandro, sorry. And I'm going to get used to these names in Mexico. And so it was a very good trip for me to be here. And I think that this is my one of the first things that I noticed that the weather is a little hotter than what we have in California. Probably it's going to be different.
You need to use the microphone, so
if they hear me fine,
no, but since it's been broadcasted.
Oh, sure.
Yeah, so they'll bring you the
They're gonna bring?
microphone. Yeah,
Yeah,
but if
that's-
you can start with the other microphone.
The other one?
Yeah.
Okay, sure.
Sorry.
No problem. No problem. Yes. So let's see if this is going to work fine. Is it working? Yes, it's working. Yes, I was just telling this is the weather is one of the first thing I noticed, and it's a little hot, but it's gonna be. I guess they'll take some time to get used to this, but people are very warm here and welcoming, and it was very good so far. And I look forward to my meetings with other colleagues here at the universities. So today is gonna be about the talk that I have been really giving to different institutions, because I have been teaching chemistry for almost 10 years at UC Davis. And every time when I teach course, I realize that there are so many students don't like chemistry. So I don't know if you feel the same thing. And there's a reason, yes, there's a reason behind it. So if you are a student and you don't like chemistry, that's not your fault. I can tell this up front. And we, as professors, should take the blame. And we are going to find out what we can do to change the perception of students and make them like chemistry again. And that is the entire goal of this presentation. First, I like to talk about the story of an apple. How many of you like apple? Yes, we like apple, right? It's one of my favorite fruits. It's delicious, nutritious, and very good fruit. And we saw this apple first in a farmer's market, where Eve was trying to convince Adam to try some. And it's free, right? Who can resist free stuff? We also saw this apple while falling on Newton's head. Newton used this accident for his advantage and developed the law of universal gravitation. And physicists studied how different objects fall under different conditions. And they also explain how invisible principles control and affect our physical world. So principles are important. We like to utilize them to explain the changes happening around us. And what we know that we sometimes make the distinction between principles and context too much. We separate these two bodies, and these two bodies cannot live together in the mind, in the bodies of our students. So this is why we think that students become less interested, and it becomes more difficult to get their attention. Now let's talk about chemistry, since this is a chemistry conference, right? Chemistry is addressing the chemical composition. In anything that we see, we like to find out the chemical elements, structures, and we've determined vitamins and minerals present in it. And also calculated amount of protein, carbohydrate, and other things you can get from an apple. This is good. And we also studied chemical structures of these compounds. We want to study how they are similar and different from each other. These are all great. We accomplish a lot. But please notice that while we are doing this, we converted that red, delicious, tasty apple to these plain structures. So do you think students will enjoy learning about these structures right away? I don't think so. Unless they have a fear of grades. Grades, marks. I know that in the United States this is a big problem. Whole educational system emphasizes a lot about getting good grades. And sometimes students think this is much more important than developing critical thinking skills, analytical thinking skills, problem-solving skills. And this is a very unfortunate thing. But that's, again, not their problem. This is the educational system problem. We put emphasis on the on the wrong place. And we know that, again, going back to these structures, they are not very interesting to our students. When they see those structures, they don't understand what they represent. And as a result, they don't want to learn a lot about those structures. So think about these structures and look at the structures reminded my experience I had in Egypt. I went to Egypt last winter to attend African conference on research in chemistry education. It's a great country. If you haven't been to that, there are a lot of places that you can visit. It's going to be a wonderful place for history, rich culture, and delicious food. So if you haven't visited, I strongly recommend going there. You're not going to regret it. While I enjoy my trip in many places, something challenged me. And then symbols, alphabet, Arabic alphabet. If you know how to read it, good for you. But I don't. They look very nice, but I have no idea what they tell. And I had similar experience at the Addis Ababa airport. I don't know if you ever used that airport. It was my first time that I was taking that airport going to South Africa. I saw this sign next to an elevator. Does anyone know how to read that sign? Okay, it's very difficult. It's Ethiopian. And it says only 4 persons at a time. So this was next to an elevator, and it saved me out of trouble because it was just after pandemic. And while looking at these signs, these symbols, I thought maybe my students feel the same thing. And they need translations of these structures and formulas. It's like a foreign language to them. It's not meaningful to these students. So when you see these things, you should not be motivated to learn them. If you are motivated to learn them, there is something wrong with you. But if you are not, that's okay. They don't look very delicious to me, like the apple we had in the first slide. So we need to make them meaningful. We need to make them delicious to our students so they can start learning about them. We know that chemistry is actually an integral part of our world. Unfortunately, I don't know when, but many years ago, we disconnected chemistry from the real life, from the society, from the environmental problems. Now we present chemistry as an isolated subject, disconnected from everything else. Students think that chemistry is only valid in this room. When you go out, they don't see chemistry. And that's why they are not interested in learning chemistry. In chemistry classrooms, in chemistry education, we use this triangle, very important triangle. We call this chemistry triplet. This triangle emphasizes the importance of connection. In order to understand chemistry, we have to make connection between these levels. Macroscopic level, and that is on this side, if I can find that here, and submicroscopic level, and symbolic level. So we start our journey most of the time at the macroscopic level. But that's not enough to understand the systems, how they work, and how they function. We need to investigate them at the submicroscopic level as well. Then we can present them using symbols and formulas and structures. if we can put them all together, then our students will be successful. So they are supposed to operate in the heart of this triangle. We need to go back and forth all the time. This is what experts are doing. But this is not easy for students to do. If they can do this in a series of mental gymnastics, then they will become very successful in chemistry. And we know that this triangle sets and lays a strong foundation for content knowledge. But something big is missing here. Something is missing. I'm not going to reveal what that missing piece is. I'll be back and let you know the answer later. So let's continue with the importance of systems thinking at this point. Maybe some of you have heard systems thinking already. It is about investigating relationships and factors that are contributing to a possible outcome. Systems thinking is also providing us an efficient way to analyze the systems and give us a chance to predict future outcomes, not based on the past events, but on the structure, an intimate understanding of structure and its elements. This is going to be very useful for everyone who is studying science. We need to utilize systems thinking approach as much as possible. In the next section, I'll give you 2 examples and tell you why we should utilize systems thinking, why it is an important approach that we should all adopt. The first example is about ozone hole. I'm sure you heard about the problem with ozone hole in some chemistry textbooks or maybe some other science textbooks. It is an important issue. Some of you might say, oh, it's already an old problem because our scientists found a solution for that. Even that's relatively old, but in my opinion, it gives us a very important chance to learn something. So that's why I'll talk about this. From these pictures, you can see the size of ozone hole. NASA took these pictures over the years. First, let's look at these 2 pictures closely. They are taken from 1970s, 1980 now. They were very small. The size, those small size you can see in the middle, that is the size of ozone hole. When we move to next 2 pictures taken in 1990s, you can see those pictures become super large. They became very large. And in 2018 and 2019, you can see that the size getting smaller once again. In order to understand this trend, we have to go back in history. We have to find what happened during those years, and so we had different sizes of ozone hole. We go all the way back to 1928. DuPont scientists from the US developed CFCs, chlorofluorocarbons, as ideal compounds for refrigerants and propellants. These chemicals are needed to keep them cold in an efficient way. And we know that older chemicals like ammonia, sulfur dioxide, and metal chloride were highly volatile, caustic, toxic, expensive, and heavy. You can quickly realize that those are not good characteristics we would like to have in any compound. That's why DuPont scientists created and developed these chemicals. Please look at the properties. Non-flammable, non-toxic, good insulated, inexpensive, light, and extremely stable and inert. Wonderful properties. And you cannot ask anything more for such compounds that will be used in refrigerants or in propellants. So they did a wonderful job. And so that's why they released CFCs on the market commercially, and they made a big deal. All around the world, companies were using these compounds in refrigerants and propellants. Until 1974. 2 scientists, Mario Molina from UC Berkeley and Sherry Rowland from UC Irvine, discovered shocking facts about CFCs. They revealed the damage these compounds making on ozone hole. And after that, they convinced the scientific community, they convinced the leaders, world leaders, to ban their use. In 1987, they were banned all around the world. And so then we started seeing improvements in ozone hole. Remember that ozone hole were getting smaller and in 2018 and the following years. So it's predicted that in 2040 or 2050, we'll have the ozone hole back what we observed in 1970s. It's taking a lot of time for the nature to repair itself. What a wonderful system we have. Actually, if the human beings do not harm anything, nature is working in harmony. Unfortunately, we do a lot of damage. Okay, let's look at the problem a little deeper. Here, I'm going to show you some chemistry, but hopefully in a meaningful way. So we are talking about those CFCs again. Remember I mentioned two properties, lightweight, extremely stable. They look very nice in the first place, but we found out that these properties cause these chemicals to migrate upward to reach stratosphere. So you should know that already. We are living in the troposphere. That's the first layer in the atmosphere. And the next layer is stratosphere. That's where ozone layer is present. So when CFCs reaches stratosphere, this is what's happening. The first thing, we see that they are decomposes due to this reaction. UV radiation and gives the energy to break down to form these chemicals. For us, the important thing that you should look here, free radical, chloride. Free radical is a substance that is highly reactive and unstable. So it will react pretty much with everything they come across. And this is, of course, in ozone layer, we find a lot of ozone molecules. They attack ozone molecules and see what is happening here. They are forming chlorine monoxide and oxygen. And you might say oxygen is good, right? We need for breathing. But it is not good in stratosphere because it doesn't have proper energy, bond energy, to absorb UV radiation. So here is a great opportunity to talk about chemistry and why it's important. You can teach the interaction between matter and energy and use this as a good context to introduce chemistry if you're a chemistry professor. Anyway, so the problem does not end here because chlorine monoxide is also unstable molecule. It will break down again, forming more free radical. That is just free radical attacks more ozone molecules. And you're not going to probably believe this, but I heard this from an atmospheric scientist. They said that one single CFC molecule can destroy up to 100,000 ozone molecules. Can you believe that? One single CFC can destroy up to 100,000 ozone molecules. That's a big ratio. This is why the problem happens so quickly and damage ozone layer. Now, what happened here? Going back to thinking, this systems thinking. Pedosphere is where we are. So DuPont scientists were concerned about this level and this system mainly, but did not consider the interaction between atmosphere and pedosphere. As a result, we had a big problem. And luckily, we were able to stop it before it gets to the point that we cannot get back to the normal condition. This is the first example. Second example. Can we try? Sorry.
Sorry.
I don't know exactly how we put this. Can you put this like that? Where do we put it exactly? I guess we can put it stuck like this.
Yeah.
I don't know really how it works.
And then you put this on.
Yeah, please.
Sorry. Goes like this. Ears.
Okay, that was easy.
The mouth.
We are learning something new. Okay, good. I guess I can put this on my back. Sorry for the delay. It looks weird, I guess, on my face, but that should be okay. Okay, so the second example has cow on the cover page, and I think that should be a good example, right? We like cows, and we have many of them on our campus at UC Davis. If you haven't visited UC Davis, I can tell a few things about it. One thing is that UC Davis has one of the best veterinary programs in the world. And we have many animals on our campus. If you visit one day, you will smell it very quickly. It smells very nice, especially if you're coming from the side where we have the places we keep them. While we love cows, they are actually causing a big problem. Who's going to tell me what problem they create? If you can raise your hand, share your ideas. What problem do they create? Methane emission, wonderful. That's right. Yes, cows is responsible for the number one source of methane emission in the US and around the world. But this is not what is happening, despite many of you might think. Most of methane comes out through their burps. As they burp, they release carbon dioxide into atmosphere. This creates a big problem because cattle farmers are able to capture their waste and use it as energy source or as fertilizers. But when it comes to burps, what can you do about that? They are helpless. As scientists, we need to help them. First, we have to put this in a larger perspective. Let's relate this to other greenhouse gases, because methane is a greenhouse gas. And when you compare its abundance, which is about 9%, on the other hand, carbon dioxide is 82%. And also we know methane persists about 12 years in the atmosphere. But carbon dioxide stays there about 100 or maybe sometimes 1,000 years. When you consider this fact, do you think we should be concerned about methane? Or we should get moving and say okay to have that much methane? What do you feel? Is there a big problem to have this much methane in the atmosphere? Yes. Why? Because methane, even its abundance rate is very low, it is much more potent greenhouse gas. It can capture 23 times more heat than carbon dioxide does. 23 times more heat. So this is why methane emissions are very important problems for us. And we are going to do something about it. I know that some people actually, yes, again, greenhouse emission will be important for us and we have to reduce this. And some people come up with very creative solutions. They are trying to capture methane by using very innovative systems. But I'm not sure how much they can capture and how they use their gas. It is not very probably effective way to deal with this problem. This is why UC Davis scientists wanted to solve this problem. And they decided to take all the cows, putting in a plane, and take them to Australia. Oh no, actually, I was joking. We are not taking our cows anywhere, we love them. We'll keep them still on our campus, but we'll bring something from Australia. We'll bring red seaweeds. Our scientists found that if you feed cows with about 85 gram seaweed, you can reduce methane emission by 70 to 90%. Do you hear this? You can reduce methane emission, which is one of the biggest problems.
Sorry, I'm having trouble with the connection. Please try again in a moment.
I guess this is not me. Yes, we can reduce methane emission about 7 to 9%. Just 85 gram, which is 1 to 2% of their daily food intake, we can reduce and get this problem resolved. So what we see here, we are able to solve this problem by bringing land system with water system. And this is the importance of thinking about the connections. This is the importance of using systems thinking. And if you like to solve the problems around the world today, we have to approach and we have to actually adopt and use systems thinking as much as possible. If you are interested about this study and want to learn more about it, please reach me out after the talk, so I'll be happy to share this. Let me tell you actually what problems we face in our classrooms and educational system. As I mentioned, as researchers, as scientists, we like to solve the problems. And we start our observations mostly at the macroscopic level and study them at the submicroscopic level and develop some concepts, theories, principles, and models. And we become very excited, right? It's our right to become excited. And when we become excited, we like to go to classroom and share our excitement with our students. And we start teaching those abstract concepts. And we hope that our students will see the same thing that we see in those structures. But it doesn't happen. They don't see what we see in them. They probably see these puzzle pieces. They think that we are giving them all meaningless puzzle pieces. They don't know where we are going. They don't understand our purpose. And this is why they become very less interested in the topics we are teaching. They don't know yet if they put these pieces together, they will create this beautiful view. And they don't know yet there's a problem that needs to be solved, and its solution will help people, animals, and the nature as a whole. And I know that if they see this purpose, they will do everything, anything possible to put the puzzle pieces together. But this is not happening all the time. So let's explore the reasons behind the lack of motivation. Research indicates that as students age, they become more and more interested about societal and environmental issues. But at the same time, curriculum covers these topics less and less through the education system as they move to higher education. There is a problem here. Let me remind you how the kids look like, so you can put yourself like in this picture, when they came to our classroom. These are the students from kindergarten. What do you see in this picture? Can you tell me what you see? What does pictures tell you? Can you raise your hand? There are a lot of students here. I'd like to engage them. What do you say? Can you say one more time? Happy. They are happy. They are eager. They like to learn. They like to explore. And look what we have done to these kids after 12 years. That's our products. That's our products. Educational system is doing something wrong. Why we change them to these kids? We change them to these kids, and Carl Sagan actually summarizes the process very well. Every kid starts out as a natural-born scientist. I truly believe this. And then we beat it out of a few of them. If we trickle through the system with their wonder and enthusiasm for science intact. Very unfortunate, but this is true. We see this all around the world. Not only in the United States, not only in Mexico. I give this talk in many different places, and every time they indicate that they observe the same thing. Why this is happening? Because of the teaching methods, because of the content we are using. So, lecturing. This is the room where we lecture. Why we lecture? I don't know. I have no idea who came up with the idea of lecturing. I can guarantee that this person wasn't an educator. Maybe a businessman. Because you put one professor in front of 100 students, you think that the knowledge will be transferred from one mind to 100 minds. I wish that would be that easy. It's not. It is not. So then, people studied how lecturing is effective. So please look at the data here. This is the data giving us brain activity. So electrodermal activity, electrodermal data, and showing class time. So please look at the class time. Almost no brain activity. It is similar to watching TV. And our brains are even more active during sleep. So maybe we should ask our students to sleep rather than coming to lecture. Don't do this. But that's what I'm feeling to say when I see this graph. And then students complain. They don't remember what they are introduced in the previous semester. They cannot retain knowledge because they don't learn. Maybe they memorize. Memorization is not going to stick to their minds. Okay, so is this something new? No. I look at on internet, I found this picture from University of Glasgow taken in late 19th century. Do you see much difference between these two pictures? What is that? Their dresses? Interest, okay. And also we can say that there's not much change in the teaching methods, there's not much change in the teaching content, but fashion has changed. Unfortunately, we are not really moving forward. We are still sticking to the tradition. We like to stick and do the same mistake again and again. I don't know why. So if you find the answer, please let me know. Okay, so then question is, why cannot we make chemistry meaningful, relevant? Why the change we are expecting to happen not happening? Let's find the reasons. A couple years ago, we developed a survey and administered survey to professors teaching chemistry in the United States and Canada. 122 professors participated in this survey. It was a magical number. I didn't expect that many professors will participate. 122 professors. Then they said, we are using these methods to make chemistry relevant, sharing real life stories, introducing applications of the principles, discussing about different uses of chemicals, and integrating social scientific issues. I was very happy to see these answers. But the next question surprised me. Then we ask, to what percentage do you dedicate your classes to covering these topics? So on the right side, there are answers, and the left side on the pie chart, we see the portion of the faculty who gave the answer. So can you predict what 55% of faculty told us? 55% of faculty. 3%. You are a realistic person. Yes. Less than 5%. They can only cover very tiny little bit of their lectures dedicating to these topics. And the rest, 39% said they can only dedicate 5 to 25% of their curriculum to these topics, and the rest will be others. So obviously we have a problem here. Then you should be asking, why? Why this is happening? What is the obstacle that prevents them to doing more of these topics? What might be the most common answer you think here? What is that preventing them? Education system structure. That's the overall answer. Very good answer. And more specifically, what would you choose among these answers? Time. That's right. Time was the most common answer we got for this question. It is an issue, and we actually were talking before this seminar, we have a problem in chemistry departments especially, because we have very fixed, rigid curriculum. We cannot change even little things here and there. You say, no, this is important. This is also important. That is also important. Yes, they are all important, but we have a very limited time. How can we teach all of these topics in a meaningful way? And if we teach everything, students will not remember, retain next quarter, next semester. So then why do we teach? Because it makes us happy. We say, we taught it. We finished our job. This is I don't know. This is another question that I couldn't find an answer. And I'm looking for help here. Anyway, so we also ask professors, how will they compare student engagement with these activities? Meaningful and relevant discussions. One professor said students are only concerned with what is on the test. Is it true? Okay, another said they just don't care. I'm going to prove that this is not right. At the end of the presentation, I'll show some students' opinions, and you will understand why this is not right. Another professor said today's students are more interested in their cell phones than socioeconomic issues. Another professor said, all I know is that at the end of the semester, ratings. This is student evaluations. I don't know if you have student evaluations here. You do? Okay. So that's what they care about. If the students say good things about their professors, they're happy. Okay, let's move to the next one. As I promised, I am going to reveal the missing piece in the triangle. Remember, I show you this triangle and I told you that something is missing here. Now it's time to reveal that. And if you should quickly notice that this is not a triangle anymore, this is now a tetrahedron. And that missing piece at the top. What could be that missing piece? Could you go ahead and predict that? What should we add to this picture that it will look more complete? Any predictions? There's no penalty. You can make the craziest predictions ever. You can say yourself may be missing in that picture. Anything? Education. Okay. Applications. Applications. Okay. That could be good. And we'll actually put a more holistic category here. And we call this humanistic approaches. So why humanistic approaches are important? We as human beings are doing the science. We are studying and we are making impact in a good way or bad way. Remember ozone hole? Who is responsible for that problem? DuPont scientists. And remember co-example, methane emissions. Who solved that problem? Human beings. So we can actually make good impact on society, on environment, or bad ones. We shouldn't forget this. And also, I should indicate that in this picture there are 3 layers. In the first layer, the emphasis on acquisition of chemical knowledge and practices for later applications. In the second layer is the emphasis on understanding the utility of the knowledge for real life and society. At the top level, the intent is to promote chemical critical thinking for sustainable action and socio-eco-justice. If we can address these goals while creating our curriculum, we'll get the best curriculum possible. And that should be all chemistry educators, all scientists' goal in teaching courses. In the next few slides, I'm going to show you some pictures so you can relate science or chemistry particularly to real life situations. And also, hopefully these pictures will help us to reflect on what we have done on this beautiful world. I don't know if the music will play, but if that doesn't play, that's fine. You can still see the images. Play. We can solve the issue. We have the knowledge. As long as we have the willing power, we can get rid of these problems. But we need every student to believe this goal. And as educators, as chemistry educators, we feel and we should feel responsible for ensuring that they can get the knowledge and skills for solving these problems. And that is what we're going to discuss in the following slides. How can we really turn these problems into opportunities? And I think that, and I believe truly that what Linus Pauling said in early 1984, chemistry has been part of society, has been part of politics, has been part of environment. And everything and anything you can think of can be connected to chemistry. And we shouldn't really disconnect it from the issues that we are facing. And we have to change this. We have to make sure that chemistry education, science education, embraces all these issues we are hearing in the media as soon as possible. Then we can actually make the change happen. In order to make this in an effective way, I suggest that we utilize United Nations Sustainable Development Goals. These are very vital goals. They are set by United Nations in 2015. And we are supposed to achieve them by 2030. So obviously, we don't have much time left. We need to act quickly so we can achieve these wonderful goals. And that's, again, our responsibility as educators, as professors. We need to give this message to our students in a very clear, in a very simplistic way, and at the same time in the most powerful way possible. I know that we can do this and create this beautiful world. Let's remember these meaningful objectives that we have for education for sustainable development. They sound like a poem to me. Let's read them very quickly. ESD aims on enabling students for shaping actively an ecologically compatible, economically powerful, and socially fair environment for living under consideration of democratic principles and cultural diversity. What else can we ask? To me, this is a perfect world that we can create all together. And we have to do this again as soon as possible. And here, let me actually give you another reason why we should utilize those topics. I used to go fishing a lot. And I don't know if you have anyone interested in fishing here? No one? Okay, few people. Okay. So you should know, in fishing, in my opinion, there are two golden rules. If you want to catch the right kind of fish, you need two things. A good hook and right kind of bait. If you have them, then you have a good chance of catching the fish you want. In a similar way, if you want to catch students' attention, so I hope that students will not be offended with this example, we need to use cognitive hooks in the context. So context, you can use this as a bait. We have to capture and sustain their attention so we can teach those principles will look like abstract and maybe boring initially. But if they know that this is necessary to solve the problems that we are facing in today's world, they will be motivated to learn those abstract concepts and principles and be successful in the future. Okay, how do I know that this is going to work? We did a study, and a couple of years ago, we chose a topic and investigated the impact on students, motivation and self-efficacy. Actually, when you look at these pictures, I'm going to ask what you think and what you feel and what you see. But first, let me tell this. Unfortunately, I don't go to gym very often. And I admit that. I should do more often. But when I go to gym, I see these faces. And that's a very common picture for me. So what kind of feelings do they have, do you think? Are they having joy or pain? Pain, right? So do they give up or they continue? They continue. They don't quit. They do another rep. They lift another, maybe, I don't know how many pounds. They increase their limits, and because you have to lift a heavier weights every time, so you can see the results. And what we can tell here, that they have great motivation, and they also know that they can do it. This is self-efficacy. And combination of these two important, effective factors giving them the results they like to see. So we have to establish these feelings in our classrooms. If we don't, these are the pictures we are going to see. We don't want to see them, right? We like to see high-level motivation. Okay, how can we achieve that? We have to make content relevant, because we know that motivation and self-efficacy are closely connected to the student's perception of relevancy. If they know that what they learn will help them, and at 3 different levels, especially individual, societal, and vocational. So the content they are learning will help them individually, will help their societies, and their future jobs. And then they will be motivated. In order to achieve this, there's an effective way to do this using social scientific issues. They have been proven to be effective in enhancing student perception of relevance and improving their critical thinking skills and reasoning skills. We can do this if we choose the right topic. So, in our study, we chose phosphate sustainability as a social scientific issue. Why? Because we know that phosphate has been announced as critical resource. We have a supply risk. It is becoming more expensive every year. And there is no substitution. You cannot go to laboratory to create something to replace phosphate. No way. And we need it in fertilizers, we need it in food items, and we need it in many other items we use in our lives. And the other final thing, there is no good method of recycling. So once we use it, it goes to sewage, which is very bad. And this is why we chose this topic. Another thing that we should consider about phosphate reserves are very limited to few countries. And actually, 75% of phosphate reserve comes from only one country in the world. Now, another prediction question. Which country is this? You can say Mexico, United States, China. Unfortunately, none of them is correct answer. Which one? France. You're getting closer. You're getting closer. You're getting away. Okay, it's going to take a long time to get that. It is actually Morocco. It's very difficult to predict, I know. So very few people know this, but that's very surprising, right? Morocco and Western Sahara area has the 75% of war reserves, and that is actually scary to me. And you might just maybe disagree, but I think that you will understand why I'm scared about this fact. In Ukraine, we were getting a lot of the food items, especially African countries were getting their grain from Ukraine once the war began there, and now they are having great difficulty of finding their food. And tomorrow, if something happens, Morocco, that area, then all countries will suffer because we will not have enough phosphate. Isn't that scary enough? So we have sustainability issues and we need to do something about it. Anyway, so as I mentioned earlier, we studied how these discussions impact students' motivation and self-efficacy. In order to do that, we recruited 760 students. They were all enrolled in general chemistry course. And we gave them 2 surveys. The first survey was music inventory to measure the changes in motivation. The second survey was chemistry self-efficacy survey. If you would like to learn more about these surveys, we can talk later, and due to limited time, I have to move fast. And this is the design of the study. So basically, we created a Prezi learning module. You see that's cover page on the site. Then we follow the steps as I explained on the left side. We gave them pre-surveys and then gave them link for Prezi, and then they came for discussion session, just 50-minute discussion session. They adapted different roles, farmer, environmentalists. They tried to defend their viewpoints. We didn't want them to say, oh, I agree, and then move to the next point. We want them to have discussions, because in the real life, you will have maybe fewer moments that you will agree on everything with your partners, with your team members. You need to know how to defend your ideas using scientific argument. Okay, and then we gave the post-test, and here are the results. Due to, again, limited time, I'm going to give you the most important results we identified. After 50-minute discussion and exploring one present module, students' motivation levels and self-efficacy levels statistically improved. There was very good evidence for us that this method works. This method is effective. And then in the future, we are going to use more of these discussions. And I can show you this paper. This is the paper that we published all the results we found. If you like to read this paper, you can either take the picture of the QR or you can send me an email. I'll share the paper with you later. The other study we did in this context, focusing on perception of science relevancy and career aspiration. The same positive results. And every time we use social scientific issues in our courses, students' learning gains increased. Let's continue with some perception survey results. At the end of the study, we asked students what they think about the study. One student said, it is a very important topic that more individuals should be aware of. Another student said this, and this was one of the best comments I ever heard. This issue is far more important than my grade. Can you believe a student says this? More important than my grade, as it impacts human survival. Do you remember what I told about the comment one of the professors made? And he said, or she said, that they don't care. That's not true. Students care. But you have to show why should they care. Okay, finally. We can actually, as chemists, as chemistry professors, or chemistry students, or science professors in general, have big responsibility. We are going to solve these problems. And we need the help of every citizen. We need the help of every student. And I believe, truly believe that every one of you, no matter where you are in your education right now, can contribute to these problems. Maybe you are going to join a research group. You're going to find a tiny little bit information that can help to solve one of these big problems. We know that these big problems cannot be solved by individual groups or teams or countries. We need this global effort, and you can be part of it. Also, we know that chemistry and science has a big responsibility to create long-lasting impact. This is going to be an excuse for us to change our teaching practices. Let's use this as an excuse and maybe talk to our chairs, talk to our deans, and request the change to take place right away. And we know that chemistry alone cannot address these issues. We have to change entire science curricula. We have to take an interdisciplinary approach or transdisciplinary approach, depending on how the problem actually occurs. And finally, I shall just encourage every one of you, especially professors, lecturers, to change their curriculum to some extent. You don't have to change the entire curriculum at once, but you can introduce some of these ideas one at a time, and as early as possible. That's the probably critical thing. We have no time to waste. We should do these changes early, and so we can hopefully get this problem solved. I would like to acknowledge my students' efforts. They are all undergrads, work with me to create the present learning modules and collect data and publish those papers, and I'm grateful for them. They all graduated. Now they are studying or working in different places, and thank you for your attention. Our apple is back, if you're wondering where it went.
Muchas gracias, Ozcan. Thank you a lot.
Thank you.
Hay tiempo para algunas preguntas. No sé si alguien tiene alguna pregunta, algún comentario.
Thanks for the talk. It's very, very motivating.
Thank you.
When you go to environmental problems as a interest catcher, it's easy, no?
Mm-hmm.
And there are other sustainable development goals. Which other would you use also to